The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. And a happy Monday to you all. So today we're going to go on to section 10.4 part 1, but before we do that, I had some requests for some questions. So we will take a look at those. This is from section 10.2 part 2, number 1. And we see it on the left side of the screen here. In Webassign, it says the hypotenuse of a right triangle is 1.3 units long. The longer leg is 0.7 units longer than the shorter leg. Find the lengths of the three sides of a triangle. All right, so we've got this triangle, and it's a right triangle. We know the hypotenuse is 1.3 units long. The longer leg is 0.7 units longer than the shorter leg. Well, the way I've got this drawn, this is the shorter leg over here, so we'll call that x. The longer leg is 0.7 units longer than the shorter leg, so it's x plus 0.7. Now, using the formula, a squared plus b squared equals c squared. C is always the hypotenuse, so this is c. We'll let this side be a and this side be b. So using the Pythagorean Theorem, we get the following. X squared plus the quantity x plus 0.7 squared equals the quantity 1.3 squared. Okay. So we have x squared plus x plus 0.7 times x plus 0.7 equals, let's see, 1.3, the quantity squared, I believe, is 1.69. And it is. Okay. Now, foiling, we get x squared plus x squared plus 0.7x plus 0.7x plus 0.7 times 0.7 is 0.49 equals 1.69. Let's verify that. 0.7 squared is 0.49. Okay, combining like terms, we get 2x squared plus 1.4x, 0.7 plus 0.7, 1.4, plus 0.49 equals 1.69. We'll subtract 1.69 from both sides of the equation. We get 2x squared plus 1.4x minus 1.2 equals 0. Again, if we take 0.49 minus 1.69, we get minus or negative 1.2. Okay, well, I've got a second degree or quadratic equation in standard form. Let's go ahead and get rid of the decimals. So we'll multiply both sides by 10. So we get 20x squared plus 14x minus 12 equals 0. But now, in fact, I can reduce it by a 2. 2 goes into everything. So I've got 10x squared plus 7x minus 6 equals 0. Okay. Now, if we use the quadratic formula, we'd get, let's see, a is 10, b is 7, and c is negative 6. Now, this a, b, and c is not the same as this a, b, and c. Okay, so don't get those confused. So now we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's see here. Let's see if we can get this x equals -7 plus or minus the square root of 49. We've got minus 4 times 10, which would be what, -40 times -6, which is going to be a positive 240 all over 20. X equals -7 plus or minus the square root of 289 all over 20. X equals -7 plus or minus, well, let's see. The square root of 289 comes out exactly as 17 over 20. So now we've got x equals -7 plus 17 over 20, which is 10 over 20, or 1/2, or 0.5. And the reason I'm going to write it as 0.5 rather than 1/2 is because the original problem had decimals. Either one would be correct. Or we've got x equals -7 minus 17 over 20, which is -24 over 20, which is negative, let's see, if we take 24 divided by 20, we get, so -1.2. All right, now, as I mentioned in the video last week, when we're dealing with distance or length or width, we can't have a negative value. So this x could not be -1.2. All right. So x is going to be 0.5 units. X plus 0.7 would be 1.2 units. So in answering the question, the shorter leg would be the 0.5 units. The longer leg would be 1.2 units. And the hypotenuse, which was given, is 1.3 units. Any questions on this problem before we go on and look at another one? Okay, now we're going to take a look at problem number 4 in this same section. So again, this is 10.2 part 2, and this is number 4. A large city in the ancient world was square-shaped. Okay, so we're dealing with a square. Measured in miles, its area numerically exceeds its perimeter by about 119. Okay, so the area would be in square miles and the perimeter would be in miles, but they're just saying numerically, so sort of ignoring the units. Okay, its area, so the area exceeds its perimeter by about 119. So the area is greater than the perimeter. Okay, how much greater? The area equals the perimeter plus 119. Okay, now, since this is a square, let's just call each side x. Okay, so the area would be x squared, the perimeter would be 4x. So x squared equals 4x plus 119. Any questions where I came up with that equation? All right, so I'm going to subtract 4x from both sides and subtract 119 from both sides, and I get the following equation: x squared minus 4x minus 119 equals 0. Okay, so we're going to use the quadratic formula. A is 1, B is -4, and C is -119. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. X equals, the opposite of -4 is +4, plus or minus the square root of -4 times -4 is 16. And then we've got -4 times 1, which is -4, and that's times -119, which is a positive 476 all over 2. So x equals 4 plus or minus the square root of, let's see, that would be 492 all over 2. Well, let's see if 492 is a perfect square. So let's see here, square root of 492, and it's not. Okay. So it says in the problem, find its dimensions, round to the nearest tenth. Okay. So find the dimensions, round to the nearest tenth. All right. So we've got two possibilities. X equals 4 plus the square root of 492 all over 2. X equals 4 minus the square root of 492 all over 2. So the top equation, parentheses 4 plus the square, oops, calculator wasn't on, parentheses 4 plus the square root of 492, close that up, close up the entire numerator, divided by 2 is 13.0, let's see, it said to the nearest tenth. So it's 13.09. This is the tenth. The 9 would round up, so we're going to get 13.1. Okay. And then if we take the bottom one and put a minus sign in instead, we get negative 9.09 or negative 9.1. Once again, x is a distance or length or width, so it can't be negative. So let's see, what does it say to do? Find the dimensions. Okay. So x is going to be 13.1 miles. Now, the instructions can be misleading, and students have a lot of trouble with this. Notice over here, it says smaller value, larger value. Okay. Well, since it's a square, both values are going to be the same. And as you can see here in the Webassign, 13.1 miles is the answer for both. So be careful with that. Just because it has a smaller value, larger value, it's kind of poorly worded. It should just say, I suppose, one value, the other value, but they're the same values. Okay. Any questions about that problem? All right, so give me a minute here. I'm going to stop sharing, go to that, and we're going to go to another student's question that's similar to one we just did. Okay. This again is problem number 4. All right, so now we'll go back and look at the Webassign screen. This is another number 4. This is still 10.2 part 2 number 4. Same idea, just a different number. A large city in ancient world was square shaped. So we'll call this x, 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 x. The area is going to equal what? X squared. The perimeter is going to equal 4x. So we've got x squared equals 4x, only now it exceeds it by 132. Okay, so everything's the same except that last number. Subtracting 4x and subtracting 132 from both sides, we get x squared minus 4x minus 132 equals 0. Any questions yet? Okay, so A is 1, B is -4, C is -132, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, x equals 4 plus or minus the square root of 16 plus, and let's see, -4 times 1 is -4, and that times -132 is a positive 528. That's all divided by 2. X equals 4 plus or minus the square root of, let's see, 528 plus 16 is 544 divided by 2. 544 is not a perfect square. So we get that possibility as well as that possibility. Going to the calculator again, parentheses, 4 plus the square root of 544, close up the radical, close up the entire numerator, divided by 2, 13.66. So that's going to be 13.7. And then the bottom one, that's going to be negative 9.7. You're going to throw that one out again because it's a negative. And so we get the two sides. So the smaller value is 13.7 miles, and the larger value is 13.7 miles as well. Okay, now, any questions about that one? All right, give me a minute here. Let's see. Got to do a lot of switching around of stuff today. My apologies. It's going to take a little bit here. Okay. Okay, now I need to get rid of that. And get rid of that. Hold on, we're going to get there. Oh, okay. Okay. So now can you see a graphing screen in front of you?
Yes.
Okay, great. Thank you. All right. So what we're going to look at today is we're going to graph second degree or quadratic equations, or in fact, quadratic functions. We're going to start with the most basic quadratic function, and that is f of x or y equals x squared. I don't recall if I've mentioned it before this quarter, but whenever I'm graphing something that I don't know anything about, I have no ideas about it, I tend to use a table where I let the x values or the input values go from -3 to 3. So that's why I'm starting with that, okay? I'm going to go through and do the calculations for the y values. So let's see here. F, oops, I guess I'll switch over to it's black. It shows up better. Okay, so f of -3 equals -3, the quantity squared, which is +9. Okay, f of -2 equals -2, the quantity squared, which is +4. F of -1 equals -1, the quantity squared, which is +1. F of 0 is 0 squared, which is 0. F of 1 is 1, the quantity squared, which is 1. F of 2 is 2, the quantity squared, which is 4. And f of 3 is 3, the quantity squared, which is 9. Any questions about my calculations there? All right, let's go ahead and plot those points. So -3, 9 is right there. -2, 4 is right there. -1, 1, 0, 0, 1, 1, 2, 4 and 3, 9. Notice, first of all, either I've messed up big time or it's not a straight line. And in fact, it is not a straight line. Also notice there's some symmetry. And look at these two different x values have the same y value. And again and again. Now recall that a function can have that. You can have several people with the same birthday, several inputs going to the same output. It's when you have one input going to several outputs that it's not a function. So this is a function. And let's draw a picture of it. Here we go. All right. This is called a parabola. Not a parabola, but a parabola, P-A-R-A-B-O-L-A. And we say that this parabola opens upwards. Okay, so think of it as like it'll hold water. If we have one that's facing downwards, like this, we say that it opens downwards. All right. Now, some characteristics of this parabola. When it opens upwards, the lowest point is called the vertex of the parabola. For this particular parabola, the vertex is at the ordered pair 0, 0, or the origin. Also notice that this parabola has some symmetry involved. And let's switch to a different color now. Right here, the y-axis is called the axis of symmetry. Now, it's not called the axis of symmetry because it's the y-axis. It's called the axis of symmetry because if you look at it, it's kind of the folding line. If you took everything on the right side and folded it along that dotted line, it would match what's on the left side of the parabola. The axis of symmetry is not part of the parabola, but that dotted or dashed line helps us establish where that axis of symmetry is. And since it's a vertical line, its equation is going to be x equals some number, in this case, x equals 0. So for y, or f of x equals x squared, we get a parabola that has a vertex at the origin. The axis of symmetry is at x equals 0, and the parabola opens upwards. Any questions about this example before we go on?
Mr. Mayo, if it opened like folding on the y, or sorry, folding on the, I guess, horizontally, would it be y equals 0 for the axis?
Yes, yes.
Okay.
Yeah, but and for these parabolas, they will always have a vertical axis of symmetry, because the ones that have a horizontal axis of symmetry, where the pictures would look something like this, those are not functions. So we don't deal with those in this course. But yes, okay. That is correct.
Thank you.
You bet. Okay, anything else before we go on? All right, so now I have, on the left here, I have basically the graph that we just did on the previous page, okay? And now I've messed with it a little bit. And what I'm looking at is problems that are in the form of y equals ax squared. So instead of a just being a 1, like it is at the first one, now I've changed it to where a is a 2, and then finally where a is a 1/3. I use the same input values for the red function. Notice that my y values now are twice what the x values are. And why is that? Because not only are you doing x squared, but then you're taking that times 2. So I have the same x values, but the y values are doubled, okay? So instead of it being 1 unit, it's 2 units. Instead of it being 4 units, it's 8 units, etc. Okay? So you get a graph that, again, it's a parabola opening upwards. The vertex is still at the origin. The axis of symmetry is still the y-intercept, the y-axis, or the line x equals 0. Okay. Let's take a look at the blue function, h of x equals 1/3 x squared. So now, using the same inputs, my y values are 1/3 of what they were over here. So I still have a, looks like I didn't quite get the graph going through the origin there. It's supposed to be, but okay, anyway. The vertex is still at the origin. The axis of symmetry is still at x equals 0. The parabola still opens upwards. But now it's sort of wider. It doesn't climb as quickly as the original. So if we increase, if a is just a 1, it looks like this. If a gets larger than 1, it climbs faster. If a is less than 1, it climbs slower. Questions on that? All right. Let's go back to f of x equals x squared. So here's our original graph again. Now let's let a be negative, in this case, just a -1. How does that affect the graph? Using the same, let's see here, using the same inputs, now my outputs are all the opposite of the y value, because you square it and then apply the negative, right? So I get the same x values, but my y values are all negative. So now my parabola opens downwards. It still has a vertex at 0, 0, in the axis of symmetry is at x equals 0, but the parabola opens downwards. Okay, so if it's in the form y equals ax squared, if a is greater than 0, the parabola opens upwards. If a is less than 0, the parabola opens downwards. Any questions about that? All right. Now, again, we're going back to f of x equals x squared. And now we're going to use the form y equals x squared plus a constant. So I'm going to use the same inputs that I do with the original, only now look at my y values. Well, I plugged in the x value and squared it. -3, the quantity squared is 9. But then I added 2, so I got 11. -2, the quantity squared is 4. But then I added 2, so I got 6. So all of these y values are all of these values plus 2. What does that do to the graph? It moves everything up 2 units. So now the vertex is at 0, 2. The axis of symmetry is still the y-axis. The parabola is still opening upwards. Okay, let's say vertex. Take a look at the blue graph. Now we're going to take the same x values and square them, and we get these values, but then we're going to subtract 3. So these values are 3 less than those values. So the parabola moves downwards 3 units. So now our vertex is at 0, -3. The parabola still opens upwards. It still has an axis of symmetry. That's the y-axis for the equation x equals 0. But so adding a constant out at the far end moves the graph upwards or downwards. Okay, any questions about that? All right, now we're going to go inside the square. So we've got f of x equals x squared. Okay, same graph we've started with each time. Now we're going to use the form called x minus h. And h is just a letter they use in the formula that we're building here, the quantity squared. Now, in this case, instead of changing the y values, I want to change the x values. So I want my y values to match my original equation. But to do that, since it's x minus 2, and then you square it, to get the same y value, since once I put x in, I'm going to subtract 2, I need x to be 2 larger than these values. So if I take these values plus 2, I get those values. What does that mean? Well, Look what happens when I've got an x minus 2 inside. The graph moves to the right 2 units. So it goes sort of the inverse direction of what you would expect, okay? So x minus 2 squared, the graph moves to the right 2 units in a positive direction. Take a look at h of x equals x plus 1 squared. That moves to the left, or negative 1, okay? So again, it's sort of the oh, this should have had a squared on it, my bad. So it's the inverse of what happens inside, all right? So now, where is the vertex here? It's at 0, 0. Here it's at 2, 0. And here it's at negative 1, 0. Okay? Any questions yet? All right. So now we've got one with a whole bunch of stuff going on, okay? So we've looked at A, we looked at K, and we looked at H separately. Now we're going to deal with all 3 of them at once. And here's what we're going to do, okay? Here's our original function, f of x equals x squared. We want to create a table of values to graph. And the way that we're going to do that is we're going to start off by putting the vertex of this graph right here in the middle of the table, okay? Now, what does the 1/2 do? The 1/2 makes the graph open wider, but it doesn't affect the location of the vertex. What does the +2 inside do? It moves it in a negative direction 2 units. What does the -3 outside do? It moves it down 3 units. So this vertex from here, what is the vertex from here going to look like? It's going to go to the left 2 and down 3. It's going to be at -2, -3. Okay. So basically, it's the inverse of what's inside and the obvious of what's outside. Why do I want to start with the vertex? Because now, by using integer values to the left and right of that vertex, I get values that are good for graphing, okay? So now let's find these points. If x is -5, g of -5 is 1/2 times -5 plus 2 the quantity squared minus 3, which is 1/2 times -3 the quantity squared minus 3, which is 1/2 times 9 minus 3, which is 9/2 minus 3 over 1, which is 9/2 minus, I'm going to multiply by 2 over 2, 6/2, which is 3/2. Okay? Any questions about that calculation and how I did it? All right, let's take g of -4. That's going to be 1/2 times -4 plus 2 the quantity squared minus 3, which is 1/2 times -2 squared minus 3, which is 1/2 times 4 minus 3, which is 2 minus 3, or -1. All right. I'm going to erase those calculations so I have room to write. So before I do that, any questions on g of -5 or g of -4? Okay. Let's find g of -3. That's 1/2 times the quantity -3 plus 2 squared minus 3, which is 1/2 times -1 squared minus 3, which is 1/2 times 1 minus 3, which is 1/2 minus 3, which is 1/2 minus 6/2. -3 would be -6/2, which is -5/2. Okay. Let's see here. -1. G of -1 equals 1/2 times -1 plus 2 squared minus 3, which is 1/2 times 1 squared minus 3, which is 1/2 times 1 minus 3, which is 1/2 minus 3, which is 1/2 minus 6/2, which is -5/2. And if I went on, you'd see that I'd also get -1 and 3/2 there because, again, of that symmetry. All right, any questions before I start plotting points? So -5, 3/2 would be -5, 1.5. -4, -1 would be right there. -3, -5/2, -2.5 would be there. -2, -3, -1, -5/2, 0, 1, and 1, 3/2. And I get, oops, this graph. So it's a parabola opening upwards. Okay, let me write that function again. G of x is 1/2 x plus 2 squared minus 3. So because a was greater than 0, the parabola opened upwards. Okay. It moved to the left 2 units. So the vertex shifted to the left 2 units. So it went from 0, 0 to -2. And then it went down 3 units. So -2, -3. Okay. So the vertex is at HK. Okay, think about this. X minus h. If we take this and write it in the form x minus h, it'd be x minus -2. And this is where people stumble with this. It's the inverse of the inside and the obvious of the outside. So it's at -2, -3. Okay, we put that at the middle of the table, and then we calculated the other values. Now, what I've done here is to explain how you would, oh, wait a second. What's the axis of symmetry? It's at x equals -2. It's the x value of the vertex. So x equals h. So we'll say axis of symmetry is at x equals h. Okay. Now, as I was starting to say, if you were doing this by hand on graph paper, this is the process that you would use. However, since we're using Webassign, now we're going to go back and look at how we would do it using Webassign. So again, give me a minute here to change things around. Let's see, get rid of that. And there. Okay. All right. So now you should be back to where you see Webassign on the left and the whiteboard on the right. Is that what everybody's seeing?
Yep.
Thank you. Okay. So let's take a look at this problem number 11 here over on the left. It says, find the vertex and the axis of symmetry of the graph of a function, And our function is f of x equals -5 times the quantity x plus 3 squared minus 4. Okay, so the form of our equation is y equals a times x minus h squared plus k. That's the formula that's in the background of what we're using here, okay? This is what we know from our examples. If a is greater than 0, the parabola opens upwards. If a is less than 0, the parabola opens downwards. The axis of symmetry is at x equals h, and the vertex is at HK. All right. So for this problem, A is -5. So this thing is going to open downwards. All right. The axis of symmetry is at x equals h. So that would be x equals, now careful, if we take this and write it in this form, it's going to be x minus -3, or just take the inverse of what's inside. So instead of a +3, it's going to be a -3. Axis of symmetry. Now, this right here is the most missed problem on the test because students don't do what I'm going to tell you you have to do right now. The axis of symmetry is not a value, it's an equation, and it has to be x equals whatever value that is, in this case, -3. If you just put in x, if you just put in -3, it's going to be wrong. Okay. In fact, here, well, we'll come back. Now, the vertex is at HK. So the vertex would be, vertex is at -3, comma, -4. So -3, comma, space, -4. Okay. In fact, here, let me do this. Let me just put in x equals -3, and I'll show you that it's going to be wrong. So I've got to come back here and I've got to change it to x equals. All right, any questions about that example? Let's do another one. Find the vertex and the axis of symmetry of the graph of the function. So the vertex is going to be at HK. H would be positive 7.5, and K is 8.5. The axis of symmetry is at x equals the h value, which is 7.5. Since A is negative, this opens downwards. Any questions on that?
So Mr. Mayo,
Yeah.
is it, since it says x minus 7.5, and then is it the opposite because it's being multiplied by the -0.9?
Nope, nope, nope.
No? Why is it?
It's the opposite because that's how the formula works. So if we go back here, let's see here, to this. Oops. It's the inverse of what's inside, and it's the obvious of what's outside. So if I've got x plus 3 inside, then I'm going to use -3 for h.
Okay, thank you.
But I've got, right, and then k is going to be -4. So let's do this one. Okay. So where is the vertex? Well, what's inside the x squared? So think of it like this, okay? Here, let's go to the next screen. Let's say, so f of x equals 5x squared minus 4. That's like 5 times x minus 0 squared minus 4. So the vertex is at 0, -4. The axis of symmetry is at x equals 0. And this thing opens upwards because A is 5. Are you following that? You see where I'm getting the 0?
Yes, I am.
Excellent. And then -4. And then this is x equals 0. And this opens upwards. All right, now we're going to graph parabolas using Webassign. And this is another case of where students will get it wrong because either they don't bother to watch the video and they try and figure it out on their own, or they just don't pay enough attention. So let's hope that none of you do either of those things. Okay, so this is how you graph parabolas in Webassign. First of all, we're going to find, let's go ahead and write this out. We've got f of x equals the quantity x minus 3 squared plus 9. We need to find the vertex of the parabola, and then after that, one more point on the parabola. Okay, so if I think of the form y equals a times x minus h squared plus k, h is 3, k is 9, right? And in this case, a would equal 1. See where I'm getting all that?
Yep.
Okay, so the axis of symmetry is at x equals h, so that's x equals 3. The vertex is at 3, 9. Okay, so the vertex is at 3, 9. The axis of symmetry is at x equals 3. So the x value of the vertex is always going to be the same x value in the equation that's the axis of symmetry. Okay, now I said I needed to graph the vertex and then one other point. I know the vertex is at 3, 9. So I'm going to pick another value. How about just one integer next to it? How about 4 comma something? Okay, so I'm going to find f of 4. And that's going to be 4 minus 3, the quantity squared, plus 9, which is 1 squared plus 9, which is 1 plus 9, which is 10. So this is the vertex. And then one other point on the graph. All right, now I come over to the graph. Remember back at the very first stuff we did, section 3.7 and 4.5, I think it was, or 3.6, where we graphed inequalities and we went and we dealt with this. Okay, we're not doing that. We're graphing parabolas. So instead, I want to click on that button, and I don't want this one. That's not the functions. I want this one. I click on that button until it turns blue. All right. Now, I do not come down here and click on the points. I go straight to the graph, and I'm going to plot the vertex, which is 3, 9. And then I'm going to plot, after that, one other point on the graph, 4, 10. Okay. And when I do that in the correct order, that will give me the correct parabola. Now, just like we could do back with when we were graphing linear inequalities, I can come over here and I can look at, oh yes, my ordered pairs are correct. 3, 9, that's my first point. 4, 10, that's my second point. Okay, so I go back here and here's my graph. Okay, and let's see what that says about the answer. Says everything's correct. Okay, now I'm going to go back and I'm going to do it wrong to show you why it matters. I'm still going to use those same 2 points, but I'm going to graph 4, 10 first. So there's 4, whoops, got to come back over here. And here's 4, 10, and then 3, 9. Oh, look what happens. It graphed a parabola going in the opposite direction because it thought that 4, 10 was the vertex. You've got to graph the vertex first, and you've got to have clicked on this button until it's blue, not down here, okay? And I know I'm whining about it, but so many students don't do it correctly because they don't bother to come watch the videos. Okay, let's take a look at another one. Let's do this one, all right? So we've got f of x equals negative times the quantity x minus h squared, or x minus h squared. All right, so y equals a times x minus h squared plus k. The axis of symmetry is at x equals 8. The vertex is at 8, 0, because there's no constant term out there, so it's like there's a 0. Okay, so the vertex is at 8, 0. The axis of symmetry is at x equals 8. I'm going to graph the vertex, which is 8, 0. Oh, but I need to find a second point, don't I? So let's go back over here. We've got 8, 0. How about 9? So f of 9 is going to be negative, and then 9 minus 8 squared, and then the plus 0. I just put that there to show that k was 0, which is negative 1 squared, or negative 1. So 9, negative 1 is right there. I'm going to check my points, 8, 0, 9, negative 1. And I would check your points before you click submit answer, because sometimes if you're not paying attention to the scale, you'll plot them incorrectly. And then, of course, you can always fix them here, right? Okay. All righty. So just a quick review. When we have something of y equals a times x minus h, the quantity squared plus k. If a is greater than 0, the parabola opens upwards. If a is less than 0, the parabola opens downwards. The axis of symmetry is at x equals h, and the vertex is at hk. To graph in Webassign, click on the parabola till it turns blue, plot the vertex, plot another point, check your points, and then go from there. Okay. Yeah. All right. So just what's coming up ahead, we're going to wrap this up tomorrow, Tuesday. We're going to wrap up this chapter. We're going to just do 10.4 part 2. And the chapter review. Then on Wednesday, we will review. Thursday is Veterans Day, no school, no classes, no Zoom meetings. And then Friday, you'll take the chapter 10 test. So there'll be no class meeting on Friday. You'll just take your test. And again, you can take your test early, but once you open it, you got to finish it before the time runs out. All right, I'm going to go ahead and stop the recording.